Welcome to the channel where all you got to do is calculate the inertia for this chassis dyno. So this is a Maho dyno that was previously used as a smog dyno, but since people have to upgrade their smog dynos, these are quite available and quite cheap. So I'm converting that to a dyno in my garage. And unfortunately, everything isn't straightforward. So we'll go into why and how, and we'll get it straightened out. This dyno has an absorber that absorbs like 150 horsepower, plus it has a inertia, so it's a combination dyno. However, the manual for it says it has 2,000 pounds, or 907 kilograms of inertia. If you know anything about engineering, you'll know that inertia is not in kilograms or pounds. So, which are different units, ironically, but that's the way they rate it. So, what I need to do to enter this information into my dyno is get the actual inertia value. So what I've done is some simple algebra, I guess, and some physics. So what we have here is my fundamental equation, which is 1/2 mv squared. That's basically kinetic energy, right? Like if you want to know how fast a ball rolls downhill, 1/2 mv squared it is equal to mgh, right? So that's your kinematic velocity, kinetic energy, I'm sorry. So, and then the equivalent to that in a rotational frame is 1/2 I omega squared. So since I want to convert what they're giving me, which is it has 2,000 pounds force. So you basically, if you put a vehicle on there with 100 horsepower, whatever, doesn't matter how much horsepower, what some amount of horsepower, it will accelerate a 2,000 pound car as quickly as it'll accelerate this 2,000 pound inertia, what they call a traction inertia, which is completely wrong, but whatever. So I'm just setting 1/2 mv squared equals 1/2 I omega squared. And that's not all the information I need, but I think they gave me all the information I need, so, or I know they did. So basically what I've done here is I've just put these, this is my knowns, I put my equations there. I also need the roller diameter, and I need that 2,000 pounds or 907 kilograms. So basically I have 1/2 on each side of the equation, so I can get rid of that. So I end up with this: mass times velocity squared equals inertia times omega squared. Now, this inertia is what we're looking for. This mass, it turns out we already have that. That's this 2,000 pounds or 97 kilograms. So we already have this one. That's a known, right? And so this one and this one have a proportionality constant, we know, right? Because the velocity has got to be proportional to the rotational speed, right? Just like if you put bigger tires on the back of your car, the same RPM, you're going to go faster, right? So, and that proportionality comes from this roller diameter. So basically what I've done is I've taken, okay, omega, that's in radians. So instead of we don't really want it in radians, right? We want it in velocity, or we want it in something linear, right? So basically this velocity and this omega are in, like, this is omega, which is like radians per second, and this velocity is in, meters per second. But the seconds will cancel out, so it doesn't really matter. So I'm just going to go with, instead of omega being in radians per second, I'm just going to say it's just radians, because the seconds will cancel out. So, and everybody knows that 1 radian is 2 pi radians is 1 revolution, so I put 2 pi there, the radians cancels out, and I get 1 revolution on top. And then everybody also knows, well, maybe not, but they should, is pi times the diameter is a revolution, so the revolutions cancel out. And so what I ended up with is, and this pi here and this pi here cancel out. So basically, my omega equals the diameter over 2. And since we already know the roller diameter, which is 0.2177 meters, divided by 2, that's 0.1089 meters. Right? So now I have kind of everything I need to solve the equation. I know my mass, 907 kilograms. I know my V, which it's not really V, it's just linear because I got rid of the per second. It's 0.1089 squared. And the reason it's that is because I just decided, okay, I'm gonna solve at omega equals 1. I could solve it at omega equals 2 or 20 million, or it doesn't matter, it'll cancel out anyway. So you might as well pick an easy number. So I made omega equal 1. So then this thing goes to 1, so that's just I. And then I just multiplied this times this squared, and it gives me 10.7585. Now when you're doing stuff like this, the biggest thing you have to understand is if you do it correctly, your units will come out correctly. And so if you see here we have kilograms, and here we have meters, which is that squared, so we got meter squared. And so our inertia comes out to kilograms meter squared, which is a unit of inertia. So I can just plug this 10.7585 after poking it into my HP48. And then I'll put that into my Your Dyno calibration page, and that's my inertia. Now, I'm sure other dynos have, you know, different versions of this and different versions of the diameter, but it's gonna all be the same. It's pretty simple math. So I could write a spreadsheet for it, but it was like squaring one number and multiply it by another, and that's kind of the answer. So, I mean, I had to divide the diameter by 2, but it's pretty simple. Could write a spreadsheet for it, and then it would work for anything, but I only need to do it once. Anyway, hope you enjoyed this. Please leave comments if it doesn't make sense, or does make sense, whatever. Let me know what you think.